Hi, welcome to clustering analysis, which is unsupervised machine learning algorithm. The clustering is defined as grouping the unlabeled dataset into different clusters. Each cluster contains the data points with similar properties, that means similar patterns such as shape of the given data point, size and color, behavior of that given data points. So these are all comes under pattern of data points. If any data points which are having same shape or similar size, similar color, similar behavior, these are all coming under same group or same cluster. For example, if we have students community who are all scored more than 9.0 CGPA, they will be considered under similar pattern students, so they will be grouped into a single cluster. And 8.5 to 8.9 CGPA students will be group into another pattern. So different groups can be formed based upon the patterns, similar patterns. The data points in different clusters should contain highly dissimilar properties. You look at here, so this is one pattern, this is another different pattern, so both are having uh, two highly different patterns. At the end of the clustering, each cluster is assigned with cluster ID. For example, this student cluster is having 9.5 CGPA, right? The range is from 9.0 to 9.5 CGPA. It will be considered as a group number 1, that is cluster ID 1. So this group is 8.5 to 8.9 CGPA. So this can be assigned as a cluster ID 2, that is group ID 2. So like that, after clustering, it has been assigned with some label that is called cluster ID. Machine learning uses the cluster ID to simplify the processing of large and complex data sets. For example, if you have 100 students in the class, then that can be grouped into different clusters based upon their CGPA. So if we have large data set like 1 lakh population in the town, that 1 lakh populations can be divided into different group based upon the age. For example, here we can say teenage from 0 to children to teenage, 0 to 18 one group, 19 to 40 one group, then 40 to 41 to 60 one group. So you look at that, we can make 60 and above will be one group, greater than 60 will be in another group. So the given data set is very huge data set, huge number of population, but all the 1 lakh people are grouped into just in the 4 clusters. So we can use the cluster ID. So this is cluster ID 1, 2, 3, 4. So just within the 4 IDs, we have included all 1 lakh people. So that is the thing. It is making easy to grouping the given data points based upon cluster ID. What is the purpose of clustering? So here clustering is used to find the hidden relationship between the data points in data set. For example, if you have patterns, same kind of pattern. For example, if you are taking cars, okay, so you are having the cars in the given image. So if you want to find out how many number of cars in the given image, suppose if I am having the image, so then I am having cars, right? So here one car, so here we are having one more car like this. So suppose if you are having the if you want to find out the pattern, similar pattern between these two objects, you can find out the hidden relationship. What is the relationship between these two objects? What is the relationship between these two objects based upon the pattern. Here we are using the shape pattern. Okay, so if I want to find one more object with circle pattern, this is also is different object, a different group. So we can find the hidden relationship between given data points. For example, dividing the customers based upon previous shopping behavior, which is used uh, this kind of pattern to recommend the items based upon their previous shopping. For example, in online shopping, if you buy the laptops, immediately they will recommend you to buy bags or mouse or wireless keyboard, uh, uh, um, wireless earphones. So like that they will recommend the remaining items, other items related to our currently purchasing or previously purchasing behavior. And identifying the hidden patterns in medical images. For example, if there is medical image, I mean x-ray, right? In the x-ray, the object, if the affected portion will be available, right? So so here it may be the diseased cell, affected cell. Here good cells, I mean normal cells will be available, so it can be able to identify the normal cells and diseased cells, okay, affected cells, damaged cells, by using the similar pattern. All right, so and in emails, spam filtering and good normal mail filtering. So this is also used based upon the similarity, like words, using the words. For example, pay, amount, and so for example advertisements, right? So based upon this words, it will be uh, classified into spam mail. Spam mail. Normal mails will be identified as, for example, if you are telling the student communication or then faculty communication, so these are all considered as normal mails. So in the spam filtering also, clustering is very much used. And identifying fraudulent and criminal activities. So if you have the pattern, that is criminal activity pattern, for example, snatching the jewels of and stealing the wallets from the pockets, and stealing the products from the shops during the shopping. So these are all called criminal activities. Fraudulent activities, that online transactions, right? Online fraud transactions will be happen within a short interval. So that is, for example, if your credit card is missed, if they have ATM pin, with the ATM pin, you missed your credit card with the ATM pin, I mean with pin number, then there is the possibility to scratch that card within the short time to get all the limit, okay, until reach the limit of your amount. So this is possible. So this is so within the short interval, within the 1 hour, okay, short interval, within the 1 hour, if they are drawing the amount 1 lakh or 10 lakhs from your credit card, then this is actually abnormal activity. Okay, so this can be considered as a fraud. Then here example is given. We are having the unlabeled data points. So for example, it is having the 200 samples. This is given to unsupervised machine learning algorithm, clustering algorithms. So here it is learning the hidden relationship between all the data points. After learning the data, all hidden relationship, here the hidden relationship is used color of given data points. So based upon the hidden relationship, color, which is recognized as three different clusters. So after clustering, it will assign cluster 1, cluster 2, cluster 3 labels to identify that group easily. Here example given with the data points, which is having the features fruit id, length, width, and weight of that fruit. Here you look at that in unsupervised learning, we will not have the label. Okay, label column will not be available. It will be available only in the supervised machine learning algorithm. Here label will not be given. A label or actual output, so it will be called different terminologies, or target output, or target output. So different terminologies they will use. So label will be represented by using the capital Y. So this will not be given in the unsupervised machine learning algorithm. So based on this, here we will apply the similarity pattern. Based upon the similarity pattern, you look at that it is grouped into different clusters. So this is the way how it will perform the clustering by machine learning clustering algorithms. Here we are having different algorithms: k-means algorithm, Gaussian mixer model, hierarchical clustering, spectral clustering, density based clustering, Cure or BIRCH. So many clustering algorithms are there. uh, Average linkage, Watts algorithm. These are all the methods to cluster the data points: minimum spanning tree clustering, k nearest neighbor clustering, BARCH, CURE, partitioning clustering. Here, distribution model based clustering, fuzzy clustering. So different type of clustering available based upon finding the or learning the similarity pattern. Thanks for watching.